So if I give you roots, these, this introduction on page 338 is going to tell you a lot of information, but to really sum it up, I'm going to use a couple of abbreviations. When I'm talking about the roots, normally there's two of them, even if they're the exact same thing, there's normally two of them. Referring them this way, that way you can see it and I don't have to write it out really fast, using that word over and over. If you are given the roots, then to write a quadratic, this is going to blow your mind. The roots are extremely useful. Okay, oh my gosh, what is this, Mrs. Myers? All right, let me explain it. If you know the roots, then by plugging in the sum of the roots here as the coefficient of x and the product of the roots here, and that will become a constant, just a number, you can start the process of creating the quadratic. Okay, so if I give you an answer, here's the roots, create the quadratic, this little piece of information is going to help you to create the quadratic in question. Let's look at example 1. Going back to our imaginary numbers. If you are given roots this and that, the positive root, so the positive imaginary number, the negative imaginary number, those are going to cancel each other out. The sum of these two things is going to be 4/3. Okay? Positive I and a negative I cancel each other out. So 2 plus 2 is 4. The denominator stays the same. The product, 2 plus I over 3 times 2 minus I over 3. So you can FOIL this and you'll come up with 4 minus I squared. And I don't know if you remember that I squared is a -1. If you have to go back and review details on imaginary numbers, that was a little while ago. And 3 times 3 is 9. So the product is 5/9. Now that I have found the sum and the product, I can start inputting the sum here as the coefficient of x and the product here as the constant, and I'll have something, Jiminy creamy, that looks more like quadratic. The sum, so I'm going to leave that A out. I'll put a line there. You'll see why in a minute. Minus the sum, 4/3 x, plus the product, plus 5/9. You guys see this? That's what they have so far. That's what they have so far. And I put that little line in front of the x for a reason. This quadratic has fractions. And normally you are going to be asked, and I'm going to see if I can find where it's written for the first time. Yes, on page 342 in the instructions, it says you need integral coefficients. What does that mean? That means whole numbers. Of course, if it's negative, it's integers as coefficients. Right now I have a fractional coefficient. Can't leave it like that. If you remember from way back when, the way you clear fractions is by multiplying each piece by the lowest common denominator. In this case, the lowest common denominator happens to be a 9. Okay, and I'm going to make it 9/1 just so that you see that. 9/1 times x squared is 9x squared. 9 over 1 times 4/3 x. The 3 cancels with the 9, causing it to be a 3. 3 times negative 4, negative 12. The 9's cancel. So here, my friends, is your quadratic after being given the roots. Now I can go backwards and I can say solve this quadratic. And if you put all these numbers into the quadratic formula, you'll come up with this answer. Okay? So this is just, if I give you the quadratic, or if I give you the roots, how do I create the quadratic? Okay? Sum of the roots is the coefficient of x. Product of the roots is the constant. If your coefficients, one or both, if your coefficient and or your constant is a fraction, multiply by the denominator, lowest common denominator, to clear the fraction, so that you have nothing but integers. That's what that means, integer coefficients. Okay? All right. Example 2. You're going to love this too. I'm still using that R1 and R2 stuff. R1 plus R2 is equivalent to the opposite of B over A, and that's using that AX squared plus BX plus C business. Okay? The sum of the roots is equivalent to the opposite of B over A, and the product of the roots is equivalent to C over A. Now the reason why I'm telling you this, and this is where we're headed now with example 2, is what if you are given a quadratic like this. This is example 2. And they say get the roots. Find the roots. Well, up to this point, you would have factored, hopefully solved it, or completed the square, found the roots that way, or plugged it into the quadratic formula. Good stuff, right? And look at how much work it takes. Look at the quadratic formula as they solve it. They give you negative 9 plus or minus the root of 41 over 4, right? Well, I've got the A value, I've got the B value, and I've got the C value. So what if I use this information, and instead of solving it the way we've been taught, let's solve it a little bit differently. Let's take the roots and let's add them together that they've given us. They've given us negative 9 plus radical 41 over 4, and they've said to add it to negative 9 minus radical 41 over 4, and they came up with negative 18 over 4, otherwise known as negative 9 over 2. Is negative 9 the opposite of that? If you remember from the original description, and I know I'm kind of going back, negative 9, if you put a negative 9 here, a negative 9 is a positive 9, right? I'm going to write that formula again. I'm going to write that new thing again. AX squared minus the sum of the roots plus the product of the roots. Okay, so I just added together the roots. Negative 18 over 4, which reduces. A negative 9, that's a positive 9. That is your A value, is it not? 2, 2, isn't that convenient? And your C value, let's do the product of the roots to prove this to ourselves. 9 plus 41. And I know this is a lot of work, but I just want you to see that it works. The product of this big long mess becomes positive 81 minus 41, all of that over 16, which in the end, after you've reduced it, reduces to 5 halves. Is a positive 5 the C value like they've told us it should be? Why, yes it is. Divided by the A value? Why, yes it is. So having this information, it is really, really simple to figure out more information about your roots. Okay? All right, I want to do some more of these. You know what, I'm going to do example 3 and then I'm going to do some more. Example 3. So, find a quadratic function such that, okay, so here's the x, such that the maximum value of f is at 8, and the graph has f-intercepts of 3 and 7. All of this information can be obtained pretty easily because of the stuff they've told us. Okay? So, bear with me for a second. If the maximum value of f is 8, the max is going to be the vertex of a parabola. And I'm just going to write that there for you. The max is going to be the vertex of the parabola. Okay? I also can tell you that the intercepts 3 and 7, where the parabola hits the x-axis, those are the roots, folks. Those are the roots. So using that little equation, that little trick that they gave you, ax squared minus the sum of the roots plus the product of the roots, I can take this information, 3 and 7 combines to give me a 10. Ax squared minus 10x. The product of the roots is 21. Okay, so I used this. Sum went here, product went here. But I still don't know what my A value is. Okay, the way I can find my A value is by using a little bit more information. A couple of different ways you can do it, actually. First off, I'm going to draw the parabola real quick so that you can kind of see it. So if this location is 8, but we don't know what this location is, but I know this is a 3, forgive how I drew it, and this is a 7, then my vertex is halfway between the 3 and the 7, which would be a 5. See, I don't have to solve anything. I just know that if 3 and 7 are my x-intercepts, the point halfway between is going to be the top of my parabola that goes with my max. So now I'm even able to find my vertex. Okay, they don't necessarily ask you all of that information. Yeah, they don't even ask you that, but I'm giving it to you anyway. Okay, so I know this is a 5, that's an 8, because this is halfway between 3 and 7. But back to the equation. I'm not done with this just yet. I'm not done with this just yet. Having this will allow me to solve for my y value. My y value is 8. My a value. 8 is equal to a times all of this. Okay? X squared minus 10x plus 21. Do I have my x value? Yes. Where 8 is the output, 5 is the x. 25 minus 50 plus 21. The sum of all that added together times a will give us 8. After you've added all that together, you should have a negative 4. And dividing by your negative 4, you should have a equals negative 2. Okay, if a equals negative 2, then all you need to do is plug in the 2 there, and you have 2 times x squared minus 10x plus 21 as your final answer. That's your final answer. All the things that we're learning today kind of are the final pieces to working with quadratics. Okay, this is really the final pieces, the end of working with quadratics. This is the end of the knowledge that they're kind of giving you. Okay, I want to go over the orals with you, and then I will let you get started. I want to do some orals with you, so please turn to 341. The easiest way I can help you with these is to actually let you practice them with me. Okay. They give me this. They want to know the sum, and they want to know the product. What do we know? We know that, hold on, I'm going back to the page for you. The sum is whatever the coefficient is here. That's going to be the sum. And we know that the product is whatever has fit here. Okay? So the sum is 3. The product is 6. Now, if it looked like this, the sum would be a -3, product would still be a 6. Okay? Because the original workings, if you can see it from back on one of the previous pages, it's over on the bottom of 338. In order for this to work, that negative sign affects that value there. It's on the bottom of 338. Let's do a couple more. Okay. Let's do number 5. First off, let's get it in quadratic form. I just kind of moved everything around. I moved that 3x over and I put it in the proper order. Now you're going to say, well, the sum should be a 3 and the product should be a 2. That would be true, but unfortunately this 2 has messed things up a little bit. That only works when the coefficient is 1. So the one little thing you got to do, and this isn't that big of a deal, is pull out the 2, and you end up with x minus 3 halves x plus 1. Now, this little sniglet here, that should be a square, that should be a square, allows me to see 3 halves is my sum. My product is a 1. Okay? What if you have a number 6? Supersized with a Coke. 3u squared minus 4. Do we have an a value right now? Well, we do, but it's among this mess here. So let's factor it out. Notice there's no u to the first, which is where the sum would be. Right? Remember the sum is that middle piece, the coefficient of x to the first? Well, in this one, we don't have a u to the first. That means your sum is 0. Your product, since we factored the 4 out, and the normal product is a positive, they've got that as a negative, so that means it is a negative 4/3. That is a negative 4/3. We're not going on to example 4, so don't stress about that. Top of page 342, number 7, number 7, number 7. I've already given you some of your work. Top of page 342, number 7. They say to you, the sum of the roots is 3. The product of the roots is 4. Give me a quadratic that represents that. Well, I'm going to start with my x squared, since this is a positive, minus 3x And since that's a positive, it stays positive. There's your quadratic. Sum, if it's a positive number, is simply the coefficient here. If it's a negative number, the negative flips that sign. Since this is a positive, this will stay positive or negative, but dependent upon the value there. And you won't really, it'll be pretty clear to you when I keep going with you. Number 9, I think, will help a little bit too. Number 9, the sum is a 0. So that's the coefficient of x, which means there's no x. The product is a -1. So this is going to be your C value. X squared minus 1 is going to be your quadratic. X squared minus 1. I can complete it with the 0 anyway. Okay, there is no x value there. In the written exercises, actually let's do number 11. Practice number 11 still. And then I'll let you go. Find an equation with the given roots. If the roots are 3 and -2, plug it in and find your information. The sum of the roots is going to be the coefficient of x. And since the sum is a +1, that negative sign doesn't change. The product of the roots, 3 times -2 is a -6. And since the original formula shows it as being a plus, then the sign of whatever the product is what goes here. The only time this sign changes is when the sum of the two numbers is a negative. If the sum of the two numbers, if the sum of the roots is a negative, then this sign gets flipped because it's a negative. Okay? If they give you the roots, the sum goes here, the product goes there. Now, if you end up with one where you have fractions, you have to multiply by the lowest common denominator to clear the fractions, like we did in a previous example. Okay? And it doesn't matter how big and how ugly the roots are. If you have two really ugly conjugate roots, adding them together and multiplying them together, you guys should be able to do all that because you know how to work with negative numbers and imaginary numbers.